So before we get into our third form, which is called factored form, which we'll get into on the next page, we need to talk about finding x-intercepts of a parabola. So let's say I have some random parabola, might cross the x-axis in how many places? How many x-intercepts are on that parabola? 2 x-intercepts. I've got one there, one y-intercept. But 2 places it's going to cross the x-axis. Will parabolas always have 2 x-intercepts? Why is the answer no? Other than the fact that I gave you the look, Brittany. So what do you mean by that? Well, yeah, they can't really go horizontally, though. Then they wouldn't be functions. Alyssa? I could have a parabola that looks like, you can't see that looks like that, which means how many x-intercepts? 1. Any other option? Yasmin? How many x-intercepts? None. We're usually going to have 2 x-intercepts, but sometimes there's only 1. Sometimes there are no x-intercepts at all. Similarly, if it was an upside-down parabola like that wouldn't touch the x-axis, we might have no x-intercepts. More with that, though, tomorrow. We need to talk about how to find these x-intercepts. If I have x-intercepts like this, what coordinate is 0? What was that? The y-coordinate. Both of these are in the form some number, comma 0, which actually gives me a process for how to find the x-intercepts. I want to look at the parabola y equals x squared plus 3x minus 40 and find the x-intercepts. Well, I'm just going to go and plug in 0 for y. We are going to set y equal to 0, and then we're going to solve that equation. And what do you know? When we do that, we get a quadratic equation, like we spent the last chapter on. We could solve by factoring, square roots, completing the square, quadratic formula. This is a nice, easy factorable one. So go factor it. Factor and then set your parts equal to 0. Fiona, do you have the factoring? Sam De Silva, do you have the factoring?
Yeah, x plus 8 and x minus 5.
Multiply to negative 40, add to 3, x plus 8, x minus 5. Good. And now the question is to solve by factoring. Sam, do you have the x values?
X equals -8.
And positive 5. Thank you. And I need to remember to say last names when I call on a Sam in this class. But absolutely, negative 8 and 5 are the x-intercepts, which means your parabola is going to cross at negative 8, positive 5. I have no clue what the rest will look like, but maybe something sort of like that. One more thing, though. Because these are points, I do want you to give your answers as coordinates. So that's all we're going to say for step number 2. Give the answers as coordinates. My x-intercepts are negative 8, comma 0, and 5, comma 0. Because I knew the y value had to be 0, because that's how I found the x's in the first place. I plugged in 0 for y. That's all we're doing. We're figuring out where the y value is 0. We get a quadratic equation. Then we just solve. Letter A. Let's take a look at y equals negative 3x squared minus 15x plus 18. And Molly, what's the first step in our process? Absolutely. Now, if we're going to try to factor this, what should you always do first when you factor? What should you always look for first, Laura? Is there one? Hold on a moment. Hello? Absolutely. When it's convenient. Perfect. I'll send them at the end of the period. Thank you. Bye. Michael, at the end of the period, just check in with the nurse.
Oh.
Laura, did you actually finish telling me things before the phone rang?
No.
Is there a GCF?
Yes.
What is it?
3.
-3. We're going to factor out a -3.
So it's a time still now.
I would rather you not miss new things.
It's gonna be 2 seconds.
Go very, 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 very quickly. We should get this after you factor out -3. Keep going. Factor what's left. And actually see if you can finish this problem. Brayden, do you have the factoring? So I pulled out the 3. I want to factor x squared plus 5x minus 6.
Yeah, x plus
Whoa, 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 whoa. Not completing the square. We're factoring. Multiply to -6, add to 5.
oh, my bad. X plus 3, x plus 3.
Silas, do you have the factoring?
6 minus 1.
Well, give me factors. So x plus 6,
X minus
x minus 1. Because 6 times -1 is -6. 6 minus 1, positive 5. Now, we're going to set the parts equal to 0. I'm going to say -3 equals 0. I'm going to say x plus 6 equals 0. I'm going to say x minus 1 equals 0. Do you get anything from -3 equals 0? No. The number out front doesn't affect the x-intercepts. Shay, do you have the coordinates of the x-intercepts?
1, 0, and -6, 0.
Good. 1, 0, and -6, 0. Those are the places where we're going to cross the x-axis. Yasmin? Well, because I want to go in the reverse direction. I want to, like, undistribute the -3. I've factored it out over here. Once you're fully factored, then we just set all the parts equal to 0, including that -3 out front, but that doesn't give us anything. I want to be completely factored, and then set them equal to 0. Letter B. I'm going to fill in 0. Now what? Can you factor it? Oh. Okay, I'm just going to tell you. You can't. So what? I'm hearing like mumbling, but... Okay, so how can we solve it though? We certainly do. Just not by factoring. Yasmin? We could do completing the square. That's going to be unpleasant, though. There's an easier way. Lionel? Use the quadratic formula. If you cannot factor something, or honestly, if you get something that you just don't want to factor, use the quadratic formula. Go do that. Just because we had our test on quadratic formula, that's kind of done, we're not done with it. We are truly going to see this all year long, including now when we're finding x-intercepts. Go do that and then simplify things fully, please. Okay, have a seat and now solve this using the quadratic formula. Yeah, bring a calculator next time, please. Hopefully you got 432 under your root. How can we break it down? Sam De Silva.
144 and 3.
That's going to be the quickest way. I didn't see that. I used like 36 and 4 and things like that, but 144 will get you there quickest. 6 plus or minus 12 root 3 over 2. I am still seeing on cumulative reviews some of you not finishing this off properly. When I do this, I go and separate my fraction to remind me that we need to divide both of the 6 and the 12 root 3 by 2. This is going to give us 3 plus or minus 6 root 3.
Let's go.
Say that again?
Can you factor out the 6 or whatever?
What do you mean factor out the 6?
So, if you divide out 6 or 2, you can factor it out before we get to the 12.
You mean like can't? No. If you've separated and saying 6 over 2 plus or minus root 432 over 2, and make sure you divide both of the parts by 2. Are you getting the same numbers that I'm getting for the end? Then you're fine.
Okay.
Yes. I'm just used to seeing people doing the 6 divided by 2 getting 3 and then saying 3 plus or minus 12 root 3, which isn't right. That's my issue. I want coordinates. The x-intercepts are going to be 3 plus 6 root 3, comma 0, and 3 minus 6 root 3, comma 0. And I realize those look strange, but those are perfectly valid real number places where you're going to cross the x-axis. The first one, I believe, is about 13.39, comma 0. Don't give me that, give me the exact version, but that is a real number. The other one looks like about negative 7.39, comma 0. They are real numbers, just not nice numbers. And that's how we find x-intercepts. And that's 3 of the 5 homework problems. We now need to look at our third and final form of a parabola. We'll do a little bit today. We'll do a bit more tomorrow after our quiz. Next page. We need to talk about what is called factored form for a parabola. Factored form looks like this. Y equals a times x minus p times x minus q. Factored form for a parabola. The point is, if it's factored, it is very, very easy for us to find the x-intercepts, because we just set the factors equal to 0. If one of the factors is x minus p, what's one of the x-intercepts? P, or p comma 0. And the other one would be q comma 0. We have x-intercepts at p comma 0 and q comma 0. The advantage to this factored form is it makes it very easy for us to find the x-intercepts. So taking a look at that first thing that we're going to try to graph. I want to graph negative 2 times x plus 3 times x minus 1. Hello? At the end of the period. Yep, absolutely. Yep, bye. Natalia, at the end of the period, Mrs. Chase needs to see you. Okay, here's what we're going to do. First, we need to find the x-intercepts, and we need to plot them. Find the x-intercepts and plot them. Well, I feel like since it's already factored for you, it should be pretty easy for you to quickly find the x-intercepts and plot them on your x-axis. So do that very quickly right now. Alyssa, do you have the x-intercepts? Good. Negative 3, 0, 1, 0. I'm just setting the factors equal to 0. The negative 2 out front doesn't affect things. So I'm going to go and I'm going to plot them right on my x-axis. I need to find the vertex. And honestly, once I have that, it's good enough. I'm just going to draw a parabola going through the x-intercepts and the vertex. So where will my vertex be? Could my vertex be over here? I'm seeing you shake your head. How about over here? How about like over here? Why did you say no to the first two, but maybe to that one? Okay, so it's got to be a vertical parabola. How would I find the x-coordinate, Laura? Which is going to be where? That's the point. The vertex, the x-coordinate, has to be exactly halfway in between the x-intercepts, which is where the axis symmetry is going to be. Well, what is exactly halfway between negative 3 and positive 1? Lionel? Negative 1. And if it's not like something we could just count like this, we would just kind of like find the average of those x values. We'd add them and divide by 2. Step number 2. The x-coordinate of the vertex is halfway between the x-intercepts. We can either just count like we can in this case, but it won't always be nice like that. So we could also say the x value is add the x-intercepts and divide by 2. What's halfway between negative 3 and positive 1? Well, negative 1. That is my x-coordinate of the vertex. Oh, you know what? Before we go on, is this vertex going to open up or down? And how do you know?
Down.
Why? The a value over here is the exact same a value we would have in standard form and vertex form. There's nothing new about that. So it's opening down. It's going to be a little narrower than normal. Same as always with an a value. Hands. How would I find a y-coordinate of the vertex? I've got the x now. How am I going to get a y? Lionel. You got to be a little louder. Yeah. Not just for one of the x values, though. I'm going to plug it in for both of the x values. I'm going to plug it in where the x is. Step number 3, we're going to find the y-coordinate of the vertex by just plugging in our x. Find the y-coordinates of the vertex by plugging in. Y is going to equal negative 2 times negative 1 plus 3 times negative 1 minus 1. And I'm not going to FOIL. I'm just going to use order of operations to finish this thing. I'm going to get negative 2 times, well, negative 1 plus 3 is positive 2. And negative 1 minus 1 is negative 2, so I'm getting negative 2 times negative 2, 8. My vertex is negative 1, 8. We're just getting that by plugging in.
What I'm going to say is probably going to make you a little angry.
Show the work.
Okay.
I didn't need to see the work for the x here because I guess you could just count for that. But for the y, I've got to see the plugging in.
You know what I was going to say?
Do I have to show the work?
Well, you can just count.
We're not just counting here. I need to see where these numbers are coming from. Plug it in. The good thing about you, though, is even though you, like, complain about this, you then always do that on the quiz. So do that again tomorrow, and you'll be fine. One more step. This is easy. Connect the dots. Like this. Like this. And we've got a parabola. Every form we graph differently. Vertex form, we take our parent function, we move it, stretch it, flip it, like you did on the quiz from last time, which I can't pass back yet. I'm waiting on, I think, 2 people between my 2 classes, but you should be able to get tomorrow. Then there's the standard form stuff where you do negative b over 2a, you make the table of values, you plug things in. But then we have this this factored form where we get the x-intercepts. Vertex is halfway between them, and we go from there. I would like you, in letter A on the next page, to find the x-intercepts and then stop. And while you do that, I'm going to pass out the optional review for the quiz that if I were you, I would not treat as optional. I would definitely do this to make sure you are going into this quiz in good shape. This is getting harder. You're going to want to study for this quiz. My work is already done out and posted on the website, so you can check that as you're working on this tonight. So find the x-intercepts, plot them. Good.
So I'm gonna do it again.
It's going to be a little unpleasant. Okay, I am hoping this did not take long at all. 3, 0 and negative 2, 0. And I feel like here, though, for the vertex, I probably shouldn't count. I should use that formula. It's really just the average of the x's. Michael's thinking a half. Anyone agreeing with him? Well, let's see. I'm going to do 3 plus negative 2 divided by 2. Yeah, that's 1/2. I want to do the y with you. I feel like it's actually not going to be as horrible as you think. Y coordinate. A half minus 3 times a half plus 2. I'm still not going to FOIL. I'm going to use order of operations. I'm going to simplify both sets of parentheses. I want a common denominator here. Well, this is like saying a half minus 6 halves. And the other one's like saying a half plus what? 4 over 2. First set of parentheses is negative 5 halves. Second set of parentheses is 5 halves. So what is it? Good, I just didn't hear the negative part. Negative 25 over 4. Your vertex is a half, comma negative 25 fourths. Okay, so a half, that's 0.5, I can handle that. Negative 25 fourths, the decimal may help us graph it. What is it as a decimal? Yeah, go to negative, though, negative 6.25. So 0.5 comma a little below negative 6. I'm about there. Good enough. And I'm going to go and connect the dots. Laura, you look a little confused. Anyone? Lauren?
Just like a general question, do you want us to draw in the,
Axis symmetry?
yeah.
You can. I don't need it. We'll do a little bit more with this tomorrow, including talking about how to convert to this intercept form. But I actually think you know very quickly how to do this right now. If I give you something like this, how would you convert to factored form? Oh my gosh, the name gives it away. That's all we're really going to add into this tomorrow. It's not going to be a big deal. Let me stop this.